Day 16 of Road to the Max Australia.
The Interceptor is back.
It seems to be fixed by the magic of NAS.
3, 2, 1.
We're heading north out of Brisbane up to go and see Servatus. Servatus is in the microbiome space. As you guys probably all know, very important part of your gut and brain health combination. Big shout out to our friends up at Reunited Bio, Mark Bamforth, and Interceptor, James McElroy. All the best, guys.
So that's the right one, yeah?
Sorry?
That's the right one.
Yeah, I think it is the right one.
Brilliant.
Perfect.
Hey Nigel,
Hey,
welcome back.
back. Good to see you.
Good to see you.
See ya.
Oh, what a beast.
I know. What do you think?
Yeah, I love it.
Kind of fancy, right?
we could hear it from the street.
All right.
So basically, I've joined Servatus because Wayne Finlayson, the co-founder of Servatus, asked me to join the company to work on this project, to develop and design a manufacturing process to manufacture live biotherapeutics. You mentioned the gut and the brain axis. We have completed a study for insomnia, which leverage the gut-brain axis pathways, and by treating your guts, we help you have a better sleep and fighting insomnia. So those are one of the conditions that we're going for. We have a lot of other conditions that we look at, IBD, IBS, and our key cornerstone study at the moment that is finishing on rheumatoid arthritis.
I know we've jumped straight into it, but I'm sitting here in the Ford Falcon here with the CEO for Servatus Biotherapeutics, and it's Mark Williams.
I am the CEO, but I'm feeling unbelievably underdressed at the moment. How do you compare to this jacket? This is a great experience. Thanks for having me. So Servatus is a biotech company predominantly built around drug discovery. Wayne added a portfolio of bacteria that he had been working on previously in another capacity as the origin of our platform of Biotherapeutics, initially targeting autoimmune disease, and the preclinical work that we'd been doing in the Biotherapeutics had shown some very strong signals with respect to inflammatory bowel disease in the standard animal models, and rheumatoid arthritis also in the standard animal models. But picking up one of your points, we then extended this into some of the other areas where the microbiome is implicated in human health, which is the gut-brain axis, and some of the work that we're now doing in insomnia, and also in irritable bowel syndrome. So I think that's pretty good.
That's cool, man.
Very good.
Right.
Day 16 of the Road to the Max Australia. We've arrived here at the Brain Institute, and we're really discussing a very serious subject, obviously the discussion around brain health.
So the Queensland Brain Institute celebrated its 20th year anniversary just recently. The QBI is established here on the University of Queensland campus, and it's really dedicated solely to understanding the basics of how the brain works. So there's a lot of research that's done here, basic research, and by understanding that basic research we can start to develop new treatments for diseases of the brain. And so work is done here that covers neurodegenerative diseases, psychiatric diseases and health, and really I guess it's a reflection of the growing understanding of mental health and how that affects us, and the growth in the ageing population that There's a real boom here in Australia, but globally, problems and chronic diseases and disorders associated with ageing. This is the research laboratory, Professor Jürgen Gertz, the director of the Clem Jones Centre for Ageing Dementia Research. This laboratory does a lot of work in understanding the pathomechanisms underlying Alzheimer's disease. So the team have developed a number of transgenic mouse models of Alzheimer's disease. So that's models replicating the amyloid pathology in Alzheimer's and the tau pathology in Alzheimer's. And so the team are really looking at trying to develop new interventions for improving the disease. Thank you so much for coming and taking the time out to visit us here at the Queensland Brain Institute and seeing the work that we're doing. And we're really doing it on behalf of the community that donate to the work here. So yeah, very special to have you here. Thank you.
We have a little gift.
Ah, fantastic.
There you go.
Brilliant, love it.
Life on the road, mate.
We are at the end of day 16 of the Road to the Max Australia, and we have arrived here at Queensland University of Technology. We have 3 guests here today. Please introduce yourself.
My name is Mika. I'm from Argentina and I'm a PhD student here at QUT.
My name is James and I'm a postdoctoral fellow here at QUT.
I'm Wayne, originally from Perth, and I'm a researcher here in synthetic biology.
I'm working on a biosensor amplification cascade where we had a lot of success in the lab previously building biosensors that are based on enzymes, where the enzyme which is a protein that performs a chemical reaction which you can measure, and you basically add some components onto that so that the enzyme activity which you can measure is directly proportional to the analyte you're trying to measure for use in diagnostic applications.
We have the T-counts and the plate readers. Both of them are mainly used for by Wayne and James, so they can explain a little bit better.
So a lot of the proteins we make have fluorescent tags so that we can sort of visualize them or measure how much of them. So these plate readers allow us to measure a lot of samples at once and measure how much fluorescent protein we're making.
Yeah. So a lot of it's like you don't know ahead of time what the correct DNA sequence is to get the thing you want. And so the best way to actually find it is to make a whole library of variants and then test each of those individually to find the one that you want. So having something like that allows us to do high throughput, hundreds of experiments at once. Thank you very much.
Thank you. That is so cute. It's lovely. Thank you.
Good luck to the road.
Good luck on the road, Max.
Good luck on the road
To the Max Australia.
I'll take.
Yeah, that'll do.